Alright, we're going to talk about this second poster again. We have discussed it before, right? Like the, sorry. Okay, we know this, we've spoken about this. You cannot just cancel out if you have multiple terms and multiple terms, alright? You can only cancel out if you have one term over one term. Then whatever it's the same, you are allowed to cancel out. Okay, but this is very wrong. So that is what we're going to focus on today. All right, so we're going to start with this simple one, and then we're just going to make it a little bit more complicated as we move forward. Okay, so examples. We are simplifying. Let's see, simplify. Now, guys, there are actually two things that you could do here. In grade 8, you would have been given fractions like this, and since there's only one term in the denominator, but multiple terms in the numerator, you could split the fraction up. You guys remember that? You could say, okay, I'm going to take the first term over 6a plus the second term over 6a and simplify them together. Okay, so that's kind of like the grade 8 way of doing it. It's still correct, you can still do that. So I'll write that down. You say 3a squared over 6a plus 6a over 6a. And then are we able to simplify these two on their own? What's going to happen with this first fraction? 3 over 6. 3 goes into the top once, and how many times into 6? Twice, okay? So we're going to have a 2 at the bottom of that fraction. Basically, it's a half. So you can write it as a half of 31. And a squared divided by a is going to be a. Remember that? A squared divided by a is a. You can write a half a, or you can write it as a over 2. It's up to you. Both are saying the same thing. All right, that is what we get when we simplify that fraction. And for the next one, what is 6a divided by 6a? 1. Right, so you could write it as a half a plus 1, or you could write a over 2 plus 1. But last year, as soon as you learned how to factorize, the teacher would have shown you a different way of simplifying this. Okay, which gets you to an answer that looks slightly differently from what we just got, but that actually means the same thing. So guys, the only reason why, just hang on please, why we are doing the second method is because this method only works if you have only one term at the bottom. All right, as soon as you have like an x plus 2, for example, at the bottom, you can't split the fraction up like that. Okay, so this method, let's try it on the slide, only works if you have one term. So only if one term in denominator. But if you do that, if you see, okay, there's one term in the denominator, let's put the fraction up, you'll get 4 marks. Okay, it's not wrong. I just want to show you a method or remind you of a method that will work in all cases. All right? So if you don't only have one term in the denominator, it may have multiple terms. So I'll just write the other method on the side. Okay, I think I have mentioned this before, that the whole purpose of factorizing is going from multiple terms to one term. Right? Have I mentioned it before? Sure? Yes? want to do your thing. Okay, just I have very much that in yours what I've done. So these are all the people that have already been shown. Okay. But we need potential 2 people because 2.2 individuals. And there were 20 people here. Some of those are allowed to move in there. Okay. And then you can pick 2 more people. So I have already established this guy's name here twice. Okay. And this girl is gone. Okay. So I have replaced this Anna with Brett. And I've replaced the duplicate here with Julie. So are these people going to be? No, they can choose. So I have shown that out of my people who are in my class, or in your class, these 2 wanted to go together. These 2 wanted to go together.
Is there a due date for this?
Yeah,
As soon as possible. Okay.
Thank you. All right, so we'll talk about that now, right? Okay, what was I saying? The purpose of factorizing is to go from multiple terms to 1 term, right? Now we need to remember that we cannot cancel out. So what I mean by that is we can't look at this fraction, right, and say, oh, now we did 6a and 6a. Let's cancel them out. My answer is 3a squared. You get 0 for that, right? And I'll make a big cross and I'll write BD for breakdown next term. Okay, you are not allowed to do that. So let's write somewhere on the side here. 2 terms, therefore cannot cancel out. Okay, in all caps, very important. I would love for the first time in it's my 9th year at Westford, I would love for this to be the year when no one does that in the thing. Please. It's great gift to me. My birthday next week, so just give me that gift on Friday. Alright? Okay. Okay, so we got it well. How do we go from 2 terms to 1 term? By factorizing. Then yes, but in order to simplify, we can use factorizing as a tool. Yes. Okay, so therefore factorize the numerator, or wherever you have multiple terms. It depends on the question. All right, obviously in this case, because we only have 1 term, we can't factorize 1 term at the bottom. All right, but often you'll have more than 1 term, you might have to factorize at the top and the bottom. Okay, it depends on the question. So guys, at the top there, what kind of factorizing can I do? I can take out common factor of 3a. Is that right? Because the denominator is only 1 term, so we cannot factorize it. Only factorize that. It's not factorizing really, it's just writing it as a product as opposed to look at what I wrote here. What are you doing? So I'm showing you a different method. In the first method, we split the fraction up. We can only do that if we have 1 term in the denominator. So we could do that here, but what if we have multiple terms? Now I'm showing you a method that we can use, regardless of how many terms we have. Okay, so 3a squared divided by 3a is a. Plus, what is 6a divided by 3a? 2. And that is over 6a. Now how many terms do I have at the top? 1. So now we can cancel out. Okay, now here we have 1 term. Therefore, can cancel out. Okay, now we're going to say 3 and 6. It's the same calculation as we did over here. 3 goes into itself once and into 6 twice. But now do you see that these A's cancel out, right? Because A divided by A is 1. So they cancel out effectively. So what am I left with? At the top, A plus 2 over 2. And then you can leave it like that. All have to leave it like that. Okay, this is just as good an answer as the one on the side, depending on your method that you use. Alright? If you just saw that there's one term, then you just split it up and you leave your answer like that, perfect, 4 marks. If you use this method, you cancel it out, you can leave your answer like that as well, 4 marks. Do we notice that these two are equal though? Because if I wanted to, I could split this fraction up. I could say A over 2 plus 2 over 2, which is A over 2 plus 1. All right, but guys, don't do that extra work. You don't need to. All right, you can leave your answer as a fraction. There's nothing wrong with that. Yes. This whole thing is 1 for me, the final answer. But now, what do we have here at the top? Do we see again we have 2 terms? So can I cancel out that 2 and be left with A? No. So if you are worried that you might do that, right? Just if you're rushing or whatever, leave that in brackets. Okay, now does it look like there's something there that you can cancel out? You can't cancel something in a bracket with something that's not in a bracket, right? In order to cancel something out, you have to have exactly the same thing at the top and at the bottom. Okay, so if you want to kind of prevent yourself from canceling stuff that you're not allowed to, leave those brackets around the A plus 2. Okay, it's fine. You are allowed to do that. Okay, let's do another one.
Wait, so we said that, so it isn't simpler to take out bracket.
No, not necessarily. You can do it just like that. If you want to take it out of the fraction, you can, but you won't always be able to. It depends on the type of
And why?
because I showed you the method that you did in grade 8.
No, I don't know.
I can't, because the bracket is not the same as what's at the bottom, so I can't have to cancel it.
You need both in here. No, first thing. It's simple enough to leave it. Why would not?
Because this is not simplified. Not as like yeah, but then you again have an A over 2 plus 1. These are 2 different methods. So you're getting 2 different answers, but they are the same thing.
I know.
We can talk about it afterwards. Can we not take a solution, please, on an argument? Thank you. All right, this one. How many terms do I have at the top? 2, hey? And at the bottom? Also 2. I can turn it into 1 by putting brackets around it, which I think is what you guys are thinking. Okay, at the bottom, let's just quickly check. Can I factorize these 2 terms?
No.
Is there anything that I can take out here? It's not a difference of 2 squares. It's not a difference of 2 cubes. Nothing. All right, so we're going to have to do a trick, which is just putting brackets around it to turn it into 1 term. All right, what's happening here at the top? We have 2 terms, so we cannot cancel out. So we need to factorize. Yes, that's what you always need to think, right? 2 terms, therefore factorize. What can I take out here? What can I do? Sasha? Yes, thank you. Common bracket of x minus 2. Then I'm left with, now do you guys see why your factorizing needs to be up to speed? Because now we're actually using factorizing in this question. All right? If I take out that x minus 2, I'm left with x plus 1. From the second term, if I divide by x minus 2, it's going to cancel out. I'm left with plus 3. Which we can simplify. We'll do that now. And at the bottom, remember I just have an x minus 2. But now, in order to be able to cancel that out, we just put brackets around it. And you can see that we need to do that, right? Because we have an x minus 2 at the top. Okay, so those are the things that we're going to have to cancel out. How many terms do I have at the top now? 1 at the bottom, also 1. So we can cancel out the x minus 2. And we are left with x plus 4 over 1. But please don't leave that over 1 as your final answer. This needs to be your final answer. Okay. So you can put in an in-between step where you say x plus 4 over 1. But this must be your final answer. All right. You won't leave an answer as 3 over 1. You will write it as 3. That's correct? Same thing here. Okay. You need to just leave out that over 1. Okay. Let me just see.
Remember, we looked more without the very beginning.
Oh, that's what I did, but this was the question. I just wrote the question down. Is what I did.
So it's very common x minus 3. You can't go and take out the x minus 2 behind 3. You can't take that out.
No. Because it's 2 terms at the top. Yeah. So if you do that, you'll get a 0. Okay, we're going to do one where we are dividing and multiplying technique, but we are going to use the same kind of concept. So for the first fraction, we have x squared minus x at the top, and that is then over x squared plus x minus 2. So I'm ramping things up quite a bit now. That is then divided by x squared plus 4x over x squared minus 4 times 3x plus 12, and then they wrote it in the textbook over 1, but they didn't actually have to do that, right? They could have just put 3x plus 12 in brackets next to the times, and you would then have to recognize that you can write it as over 1. Okay, before we jump into this one, how do we multiply fractions again? If we have a over b times b squared over c, let me do it like that. Come on. Right? I'm just doing an example. I want to hear from someone else, not the regulars. Yes? Yes, so I could cross cancel here, the b and the b squared, right? Is there anything that I can cross cancel here with an a and a c? No. Okay, so I'll cross cancel that one b at the bottom with one of the b's at the top. Okay, and then after you've cancelled everything that we could cancel, you are going to multiply the numerators and then multiply the denominators separately. Okay, so this will be as an answer AB over C. Yes, are we all clear on that? Okay, because we're now going to have to apply that to these fractions, which are obviously more complicated than these ones. Okay, but this is the rule. We check whether we can cross cancel, cross simplify, cross cancel, right? And then once we've done that, we multiply whatever is left in the numerators together, whatever is left in the denominators. What do we do when we divide by a fraction though? Yes? What do we call that again? We call that different times, right? So we change the division symbol to a multiplication symbol and we swap those two around. Okay. Now guys, at the moment, is there anything that I can cross cancel? Can I actually cross cancel if there's a division in the first place? No, okay. But what I actually wanted you guys to recognize is that again, in order to cancel, but then also to cross cancel, we need to have one term. And do we have one term here in any of these positions? There's a 1 over there, but any of the other places, multiple terms in all of them. So we're going to have to factorize wherever we can. Okay, so for that first one, what kind of factorization can I do at the top? Okay. Take out x. All right, then I'm left with x minus 1. Get a mark for doing that, by the way. Only one mark into this question. questions like these can't quite a lot of marks, right? Even though it's like a repetitive thing, factorizing a bunch of times and they cancel out. At the bottom, I think we can all see that this is a trinomial. Okay, you want to try?
Oh,
Sorry, I put your hand over.
x plus 2, that is, and then x minus 1.
Yes, good. X plus 2, x minus 1. All right, thank you. So we're looking for factors of 2. The difference between these factors must be positive 1. So we do positive 2 and negative 1. Okay, thank you, all right. Now this one, we're going to change this 2 times. Now, are we able to do this in one step? Can we visualize that swap? Okay, that tip. So the x squared minus 4 is going to be at the top. And x squared minus 4 is the difference of 2 squares. Yes? So when I factorize that x squared minus 4, that is now being tipped. I'm going to get x plus 2, x minus 2. That'd be 3 marks in already, hey?
But then I don't understand what x is.
Yeah.
I don't know.
So trinomial there that I factorize. Okay, so let's get back to this. We are tipping and timesing, right? So that we change 2 times. This x squared minus 4 would go to the top, and I factorized it. The x squared plus 4x will go to the bottom. And if I factorize this one, I can take out an x, right? Is everyone fine with that? So x bracket x plus 4. Okay, I'm going to flip this one. We'll flip this one. Oh, it's 8 times. Okay, so you only flip the fraction that comes after the division tool. Times. So the next one, what can I do there? Yes, take out a 3, thank you. 3x divided by 3 is x, plus 12 divided by 3 is 4. That is all over 1. Yeah, you don't have to, but it does make it easy. And especially because they wrote it like that in the textbook. But you don't have to. Guys, how many terms do I now have everywhere? 1, 1, 1, 1, 1, and then 1, right? I have 1 term in all of my fractions, in all the numerators, all the denominators. So now I can cross cancel, or even within one fraction, if there's something that I can cancel, I can do that as well. All right. So let's start from the very first thing that we have here. We have an x at the top. Now, guys, we have 3 fractions here, but I can cancel something here with something in the third fraction, right? I'm allowed to do that. Yes. So this x at the top, is there an x somewhere at the bottom of any one of my 3 fractions that I can cancel out? There's an x there, right? So I can cancel this x with that one. And remember, what am I actually doing when I'm canceling? I'm actually dividing, right? I'm saying x divided by x is 1. So we're not really going away, we're actually dividing it. X minus 1, is there an x minus 1 in the denominator of any one of these 3 fractions? That same fraction, right? X minus 1 and x minus 1. Those ones will cancel out. Let's just go to the next fraction, and you can do this in whichever order you want to, guys. If you see there's something you can cancel out, you can just do it. Okay, I'm just trying to do it systematically. There's an x plus 2 here, is there an x plus 2 at the bottom of any one of there? There. X plus 2, x plus 2. So guys, when you are drawing your lines for cancelling out, I think I may have mentioned this before, make sure that the marker, can still see what you wrote at the bottom. Okay, or what you wrote under your actual line. X minus 2, then x minus 2 somewhere? Oh, okay, so x minus 2 is going to be in my answer. But guys, if you're worried that you're going to miss something, right, if there's lots of lines and stuff going on, you can circle that. Or just do some kind of maybe make a star above it or something if you want to. You don't have to, but just so that you are sure to include that in your answer. 3, is there a 3 at the bottom somewhere? No, so the 3 is going to have to be my answer. And then x plus 4, is there an x plus 4 at the bottom? Yes. So that's what's left at the bottom if I canceled everything off. 1, right? But do I have to write something over 1? No. What's left at the top? 3 times x minus 2. Now guys, here it is completely up to you whether you want to multiply that 3 into the bracket I would say don't do it because it takes time and you might make a mistake if you're rushing and you're not going to get an extra mark afterwards. Unless they say in the question, leave your answer as separate terms or something like that, but they won't do that. Okay. It's fine to just leave your answer as the separate brackets or the 3 and a bracket, just like that. You do not have to multiply it out. In fact, if you decide to multiply it out and you think while you're rushing that that is 3 and you write 3x minus 9, I have to subtract the mark. Okay, so you're actually putting yourself at risk for losing marks. So just leave it like that. If you don't like that, you can multiply it out. It's up to you. Okay, are you ready to try this on our own? So basically, guys, you're going to have to factorize a bunch of times. Okay, and remember, we've done all sorts of types of factorizing. We've done trinomials, we've done grouping, without for that possibly. We've done what else? Difference of two squares, sum and difference of cubes. Yes, we can look out for all of those types of factorizing, okay? Let me just see here. Okay, so your homework, I'm going to give you from 2 different exercises because they've split it up like that. Okay, number 2, E, G, K, and L, and exercise 1.21. Okay, there you go. Those are the ones that you are doing for tomorrow for you guys. And see this as studying for Friday's class because you need to be able to do these things for Friday. All right, so within doing your homework, you are actually getting ready for Friday's class. Guys, if you have any questions about that crib sheet, feel free to ask me. It's basically your own, literally like a little crib sheet. All right, so whatever you think you need reminders of, you can put on there. A4, you can write on the front and the back. It's fine. You can write as little or as much as you want. It's up to you. Okay, that has nothing to do with me. It's your own thing. Yeah, that's the other thing, guys. You also don't want to put too much on there because then you might get a bit distracted. So try and, yeah, I mean, it is your own thing. Try and just put everything on there that you think you will need. Then, okay, let me just, oh, yeah, that's an O.